Hi guys, so here is a problem regarding the topic matrix, but this one is not as complicated as the others that I have left to show you. So with that said, let's get started. So the first thing that we need to know is the determinant value of matrix A equals 1 divided by the determinant value of matrix inverse A. For example, we all know that matrix A times matrix inverse A equals matrix I. Well, in this case, suppose I is matrix 2 with the dimension of 2 times 2, so it will be easier. Matrix I is here. So we all know that if we take the determinant to both sides, what we'll get is the determinant of matrix A times matrix A inverse, but it can also be written as determinant of matrix A times the determinant of matrix A inverse, which equals to the determinant of matrix I, which in this case is equal to 1 minus 0, which is 1. So we know that the determinant value of matrix A equals to 1 divided by the determinant value of matrix A inverse. So here is the proof why. Alright, so the next step we're going to do is looking at this group. So in this case, well, I like to switch the sign. For example, if I times both sides with -1, what I'll get is 2ab minus matrix A equals -3 times matrix I. So the next thing is, since I think you all seen here is matrix A is a common factor, so I'm just going to write it as A times matrix 2b minus matrix I, since A times I is A, equals -3 times matrix I. And the next thing we're going to do is we're going to take determinants. So the determinant of matrix A times matrix 2b minus I is equal to the determinant of matrix A times the determinant of matrix 2b minus I and the determinant of matrix -3 times matrix I. Since it is a three-dimensional matrix, so the determinant value is -3 to the power of 3, then times the determinant value of matrix I, which is 1. And on the left side, since we know that the inverse, the determinant value of matrix inverse A is 4, so determinant of matrix A is 1/4 times the determinant value of matrix 2 times B minus I. So the determinant value of this matrix equals -108 since I move 4 to this side. So what we're going to find next is the value of matrix 2b, and we can find it by here. So 2b is, well, you just time 2 to that matrix. So what we'll get is the matrix of 3, 2, -2, 0, 4, 0, 2x, 0, and 2y. And we're gonna minus that matrix with matrix I. So it is 1, 0, 0, 0, 1, 0, 0, 0, 1. So the result is, so here 2, 2, and I'm just gonna do the others. 0, 3, 0, 2x, 0, 2y minus 1. And to continue this, I'm going to add more columns, more 2 columns, so we can find the determinant of the dimension 3 times 3 matrix. So what I'm gonna add is the first 2, 0, 2x, 2, 3, 0. And what we'll get here is, well, it's gonna be quite difficult to see, but I guess you could. 2 times 3 is 6, and then 6 times 2y minus 1. And this diagonal, since it consists of 0, so the result is 0. Also, this diagonal, which consists of 0, so the result is 0. And then you're going to minus this, which is negative 2 times 3 is 6 times 2x, which is negative 12x. So the result is 12y minus 6 plus 12x. So in this case, the determinant value of matrix 2b minus I is 12y plus 12x minus 6 equals negative 108. So 12y plus 12x is negative 102, and x plus y, or y plus x, you could say that is equal to negative 102 over 12, which is, well, we can divide it by 6, negative 18 over 2. And since the question says that the absolute value of x plus y, which in this case equals the absolute of x plus y equals 18 times 2, and which is again equal to m over n, and m and n in this case are both positive prime integers. So m is 17 and n is 2. So it asks us the value of m minus n. So m minus n is 17 minus 2, or 15. So here's the answer to your question. So I guess that improves your knowledge about metrics a lot. So hope you like it. Thank you, and you can leave a comment down below, and I'll try to answer as soon as possible. Thank you.